And here we go. Shout out to Rhiannon and to Justine and to no one else. So we hope that the lesson is awesome for you guys. Does anybody want to say hi to them? Okay, on the count of three, hi. Okay, 1, 2, 3. Hi. All right. So a couple people flicked you off, but I'm not gonna, that's not gonna be on the video. So okay, totally inappropriate. Gina, knock it off. No more negative behavior. Gina, stop using foul language all the time. Okay, so here we go. So I know what you were wondering. After yesterday's lesson, you're like, when will we ever use exponentials and logarithms? And because yeah, because math is awesome, I'm going to show you guys where you can apply this in real life, and you'll be really happy about that. So we have two main formulas. Question. Our two main questions are, our two main equations are, for interest that is compounded at a periodic time. So, for example, twice a year, 4 times a year, once a year. And then a formula when things are compounded, when growth is compounded continuously. And so if you look at the first example, it says a radioactive substance decays in such a way that the amount of mass remaining after T days is given by this function where mass is measured in kilograms. Okay, so you can see that if a radioactive material is it decaying like, twice a week, or is it decaying all the time? And that's why the equation involves E. Okay, that's part of the reason why the equation involves E. So it says find the initial mass. Initial is when? At the beginning. So at time equals 0. So we're going to plug in 0 for the time. And when I plug in 0, I get the mass at time 0 is equal to 23 times e to the negative 0.0043 times 0. And it'll be e to the 0, which is times 23 is 23 kilograms. So that's the initial mass. Now it's decaying over time. Well, how much mass remains after 21 days? Maybe it'll be 22 kilograms. Maybe it'll be 5 kilograms. How will we know? We'll plug in 21. So we have 23 times e to the negative 0.0043 times 21. Yes. So I did just 23 e to that power times 21. Okay. Now, go ahead. Well, I will state within the problem, but if you want to write it out to 3 decimal places, that's fine. Okay, this question, after how many days does it have a mass that is half the initial? That's a lot more difficult, isn't it? Well, what's half the initial mass? 11.5. Awesome. $33. Yep. So thank you for stating. I took half of 23. I got 11.5. So I'll divide both sides by 23, and I get 0.5 is equal to e to the negative 0.0043 t. Right now, you're like, holy cow, I got to solve for that exponent, But fortunately, we just talked about solving exponential equations, right? So what do we do to both sides? Natural log. take the natural log of 0.5, we get negative 0.693 is equal to negative 0.0043t. Divide both sides by negative 0.0043. $197 days. So it's going to take about half a year, a little bit less, for it to get to half of its initial mass. Okay? So you can see how important logarithms are. Yesterday you said to yourself still, you're like, what are logarithms? Logarithms help us solve exponential equations. Okay? Let's try next one. If $1,500 is invested at 8% per year, it's compounded semi-annually, find the investment after 5, 10, and 15 years. Well, that's a little bit more interesting problem because it involves money. So do you think in this situation I'll use the first type of equation or the second type? How will I tell the difference? Yeah, it's compounded semi-annual, which means twice a year. So this is when it's compounded a certain number of times each year. This is when it's compounded all the time, continuously. And so because of that, we will use the first type of equation, which says that the amount at a given time, t, is equal to the principal, or your initial investment, times 1 plus the rate at which it's invested, divided by the number of times it's compounded during the year, raised to the nt power. So my friends have, well, I think friends, I don't know if I was in high school, they said they wouldn't talk to me, but whatever. So 1,500 times 1 plus 0.04 divided by 2 raised to the 2t power. I'm sorry, I did, yeah. I immediately did the 0.08 divided by 2, thank you. 0.08 divided by 2 raised to the 2t power. And so I'm going to actually take this and plug it into my calculator, 1,500 times 1.04 raised to the 2t power, and I'll just type in 3 values. I'll type in, 5, 10, and 15. So much math today. I'm going to put it in my table, and when I do that, as you can see from the other classes, I already have 5, 10, and 15 typed in. And if you want a more exact value, you can see that if you actually click over on the y value, it will show you to the nearest cent. So I guess I have $2,220.37. And I have $3,286.68. And I have $4,865.10. Those are the expected amounts, yes. Sure, or you could just list the 3. Yes. Oh, broad shoulders, thank you. So I'm going to give Lauren $1,000 of Monopoly money. And she gets to invest it at 6% compounded semi-annually, which is twice a year, or 5%, which is less of an interest, but it's compounded 4 times a year, or she can invest at 4% compounded continuously an infinite number of times during the course of the year. Lauren, where would you like to invest the $1,000 Monopoly money that I'm giving to you? Okay, she wants to take it and spend it. Okay, fine. All right, so do you want to invest it in 1, 2, or 3? You want to invest in the third one. Okay. All right. So it sounds like a good idea, doesn't it? Let's actually figure out if this is the best option or not. So I'm going to use two equations. I have amount after a given time t is equal to a principal times 1 plus r over n raised to the nt power. And I also have amount after time t is equal to the principal times e to the rt power. I have two equations, and by the way, these equations you'll be given on the test. I'll give them to you. And you can see that the last one is going to require the PERT equation. The first two will require the other equation. And so I'm going to write an expression. The amount is equal to the principal, which, you know, we used $1,000, for example. I'll just write P times 1 plus, do that all the time. 1 plus R is what? 0.06 divided by 2 raised to the 2t power. Now that doesn't give me an actual amount because I'm not given time, I'm not given the initial investment. But we can see this through a little bit further. But first let's write an expression for this one. So I have amount is equal to P times 1 plus 0.05 over 4 raised to the 4t power. And then the last one is the amount is equal to the principal times e raised to the 0.04 t power. Now, what do all three of these equations have in common? They have p and they have t. So maybe we could write it so that you see just a number along with p and t. Maybe that would help us identify which is the best investment. For example, we have p times 0.06 divided by 2 is 1.03, and raised to the 2t power. Well, I'm going to use up that 2. How could I use that up and make it go away? What is that 2 asking me to do? Square it. So I'm just going to square it. So I'm going to take the 1.03, and I will square it, and I get 1.0609. So now I see P and I see T, and I have a base of 1.0609. So Lauren is choosing to invest it in the very last option, which, you know, she would hope that then the number would come out to be better than 1.0609. Let's try this one. 1 plus 0.05 divided by 4, and I'm going to raise that to the 4th power. Whoop. And I get 1.0509. So right now it looks like the first option is the best, right? And that's going to generate more growth over time. The last one, I have P times e to the negative, or to the 0.04. Well, I know how to use e. I've got second natural log. I'll go 0.04, and I get 1.0408. So Lauren is investing her money. Unfortunately, she would have been better off investing it into the first option. And what we learned is that compounding continuously is generally a better deal, but you have to consider the interest rate. And when they start decreasing the interest rate on you, that plays in mind. So companies offer different interest rates over different periods of time. You need to be able to calculate that to find out what's the best deal for you. Okay. I want you to try number 4 on your own, because I believe you can do that problem. Because you're really super smart. Okay, for people watching the video, you can see that the first result is $2,477.65. On the second one, we take the log base 1.055 of both sides, and you get 12.946, or approximately 13 years. Any questions how we came up with that? Did you do it correctly? You feeling really smart? Good for you. Question, Judith. Okay, so the second part, the question is, how long for the investment to double? So if we start with 2,000, I'm wondering, when does it get to 4,000? I divide by 2. I'm left with 1.055 to the t. I take the log base 1.055 t, or 1.055. I do that on my calculator by pressing natural log of 2, or log 2, divided by log of 1.055. You should get 12.946. Okay, you guys are doing exceptionally well. Let's get to the last two problems. An investment of $800 was compounded quarterly over the course of 6 years. It resulted in $1,245.83. So they got a nice return on their investment. The question is, what was the rate of the investment? Well, I know that the amount is $1,245.83. I know the initial investment was 800. 1 plus, I don't know the rate. How many times was it compounded? 4 times in a given year, and raised to what power? 24. Because it's n times t. So that's the total number of times it was compounded. So I want to solve for r. What would you do to solve for r first? So let's divide by 800. 1245.83 divided by 800. And since I'm solving for a rate, I'm going to write this out to a number of decimal places, because a rate is usually like, to the thousandth, 10,000th actually that they measure that. So we're going to go 1.55729. I think that'll be plenty of decimals. Is equal to, parentheses, 1 plus r over 4 to the 24th power. Now what needs to move? The 24. How do I move the 24? The 24th root. Think, if it was being squared, you would take the square root. It's being taken to the 24th power, so you take the 24th root of both sides. Raised to the, parentheses, 1 divided by 24 power. And I get 1.01863. Now what? Subtract 1. And multiply by 4. And I get the rate is equal to 7.45%. So that's our rate. Go math. You ready for the last problem? It's my favorite on the page. It has rabbits. I love rabbits. They taste like chicken. Oh, jeez. You guys. So, quick start. So, anyway. All right. So, rabbits, what do? They eat, they sleep, they multiply. The population is modeled by this function. P is measured in thousands, and it's the number of rabbits at t years since population was tracked. Let's find the population after 10 years and find out how many years it takes for the population to reach 8,000. Let's do the first part. How do we figure out what the population is after 10 years? You plug in 10. So the population is 30 over 1 plus 5e to the negative 3 power. because I take negative 0.3, I multiply it by 10, I get negative 3. I type that in, I get 24.0204. So is that my answer? Is it 24 rabbits? 24,000 because it's measured in thousands. So it's 24,020 rabbits approximately. Okay. For the first part, the second part's a little bit more challenging. The second part says, when has the population reached 8,000? How do I do that? Put in what for P? We plug in 8 for P because it's measuring in thousands. And now we must pause because there are a number of ways to solve this equation. Would you like the way that I suggest to do it, or would you like me to just follow the way that you want to do it? I don't care. You want my suggestion? Okay, then what I don't like about this is that t is in the denominator. But they're both fractions, right? So what I would encourage you to do is no. I would encourage you to just take the reciprocal of both sides. The reason why I don't cross multiply is when I do it correctly, but it seems like about 30% of students do it wrong. So now how am I going to solve this? I'll multiply both sides by 30. So I have 1 over 8 times 30, and I get 3.75 is equal to 1 plus 5e to the negative 0.3t. Minus 1. Yep, 3 point. I took 1/8 times 30, and I got 3.75. Subtract the 1, I get, and divide by 5, and I get 0.55 equal to e to the negative 0.3t. Take the natural log of both sides. Very good, B. Rodden. Natural log of the answer, and I get negative 0.5978. And I divide by negative 0.3, and I get 1.9923. So after 1.993 years, it will reach 8,000 as a population. Some people looked at the problem earlier and they were like, so is the initial population 30,000? That's not the case. The initial population would be when you plug in 0 for t. When you plug in 0, you get, that'll be e to the 0, which is 1. 5 times 1 is 5, plus 1 is 6. 30 divided by 6 is 5. So 5,000 was the initial population. So it's grown to 8,000. So just clarification. Your assignment. I took off some problems from last year to try to shorten your assignment because I care about you and I know that you're busy. And congratulations, but you have caught up for all the time that we missed by not having school even earlier. The 39-day first quarter, that's now put to rest. You're caught up. We're on schedule for the rest of this semester. Get through your information for this test, and trust me, the rest of the year will be a very nice pace for you. I should say the rest of the year, meaning January 1st. So after that, we'll run into some tough spots second semester, trust me. But Because it said 57, 55 through 57, and then 64, so I just rewrote it. So there's what you have. It may look like 2 assignments. Your book chooses to cover word problems in every section. What I chose to do is teach you guys the 4 sections and then cover word problems from a couple of the sections. So just do this on 1 assignment. You don't have much time to work, but you did make it through the notes quicker than all the other classes. So way to go.